All right, we're going to revisit scale drawings here. This first problem, this is just going to be a quick kind of reminder, kind of go through the steps on how we can use a map and a scale to find actual distance, and from that find the actual, or find the speed that Claire walks. So we've got the park here. We need to find, so number one, we need to find the distance around it, so the whole parameter. So we have the scale down here, and it says that that distance is 600 feet. So from there to there, that's 600 feet. So what I did is I just measured on a piece of paper that distance, and then I went and saw how many 600 feet chunks fit in each side. So on this side, we've got 1, 2, 3, 4, 5. So 5 times 600. This distance right here is going to be 3,000, so 3,000 feet. Up here we've got 1.5, so that would be 900 feet. On the other side, we've got 1, 2, 3, 4, 5. So that's going to be right at 3,000 feet again. And then on the bottom, we have 2.5, so that's going to be 1,500 feet. Okay, so now we just add these all up to find our perimeter. So that would be 6,000 plus 900. So 6,900 plus 1,500. So that would be 8,400. So if you use a ruler, measure that out, and then say that was 2 centimeters or whatever, and measured around, you should get something close to this. You might be a little different, but for this, it should be fine. It should be somewhere close to that 8,000, 8,400 to 8,700, kind of in that range. Okay, so this is our total distance around the garden is 8,400 feet, right? Our scale was in feet, so our dimension should be in feet. So now to find how long it took, or it says it took Claire 30 minutes to walk around the garden at a certain speed. In order to find that speed, we're going to divide our distance. We're going to divide that by our time. So we've got 84,000 divided by 30. So let me rewrite this differently. Okay, and when you divide that, we're going to get the number of feet per minute that she was walking in order to get that distance. So 30 can go into 84 2 times. So 84 minus 60, that's going to leave us with 24, so 240. 30 can go into 248 times. And then we'd have one more zero. So she was walking 280 feet per minute. Oops. Okay, so there we can use our scale drawing to find distance, and then if we're given a time that it takes to go that distance, we can find speed. All right. So a scale drawing, you use a scale factor to represent an actual dimension on a map or a drawing. So just like up here, this little dimension right here, that represents 600 feet. That's the scale factor. That distance, whatever it is, equals 600 feet. Okay, now here I'm going to be using a graph paper where it's a little easier to see, like right here, our scale on this one is 100 yards is equal to 2 of those squares. Okay, so we're going to do the same thing here. We're going to use that scale to find the actual distance around this park. And the park I outlined in red. So what is the actual distance for the parameter of the park? Well, we got to count how many squares there are. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. No, actually that would be 14 because that's half up here and half down here. So we have 14 over here. We have 13 up here. Ten over here. 5 here and 4 here. Oh, and then this last one. 8 here. Okay. So we know the total distance around the park is 14 squares on this side, 13 on the top, 10, 5, 4, and 8. So if we add those all together, you're going to get 27, 37, 42, 46, and then 50. What was it? 54. So 54 squares. Now, every 2 squares is 100 yards. So we can divide this by 2, and you'll get 27. And there's 2,700 yard units in there. So we're going to times this by 100, and that will give us our total distance around the park, which equals 2,700 or 2,700 yards is the total distance around this park. Okay. Oops. That's 2,700 yards. Okay, the next question, it says, what is the length and width of the tennis courts? So if you notice, here's the 2 sets of tennis courts. They are the same dimensions. So it's 3 squares by 3 squares. On the height, you'll notice that we're off on the squares a little bit, but if you add the part on the top with the little chunk on the bottom, that's going to be a full square. So it's a 3 by 3. Oops. So if 2 squares equals 100, then 1 square equals 50. So that's going to be 3 times 50, which equals 150. And then the width is the same, it's 3, so it's going to be 150 by 150, and this would be in yards again. Okay, so last thing, it says draw a building to scale that is 200 yards wide by 600 yards in length. That is 150 yards from the park and 200 yards from 3rd Street. Okay, so we're going to draw this right here in front of the park. So it says it's 200 yards wide by 600 yards in length, but it has to be 150 yards from the park. So we're going to go 3 squares away, and it has to be 200 yards from 3rd Street, so that's 4 squares away. So 4. So right there is where we're going to start. Okay, it's 1, 2, 3, 4. It's 4 squares, which would be 200 yards away from 3rd Street, and it's 1.5 or 3 squares away from the park. So that's just to reference our starting point. So now it's 200 yards wide. So that's going to be a total of 4 squares. So from here I'm going to draw down 4. Okay. and then it says it's 600 in length. So 600 would be 6 times 2, so that would be 12 squares. So 2, 4, 6, 8, 10, 12. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. Yep. Now we come up our 4, and we just connect it. So there we've drawn to scale this building, and we've placed it 150 yards from the park and 200 yards from 3rd Street. Okay, so that's just using a scale now to actually draw a picture or dimension that we are given the actual dimensions of. Okay, so kind of keeping on this theme, we're going to use the same idea here. Right now we have an outline of a house. It tells us that 1 square is equal to 5 feet. So it says in the upper left corner, draw a room that is 15 feet by 20 feet. Well, for the width of the room to be 15, upper left-hand corner is up here, so we're going to go down 3 squares and start there. And now it's 20 wide, so if each square is 5, 5 times 4 is 20, so we're going to go 4 squares. And then we just close it off. There, we've made our room that is 15 feet by 20 feet. Okay, next it says draw a wall for the garage, so it is 30 feet by 35 feet. So 30 feet would be 6, 35 would be 7. So the garage is this little pop-out part right here, and as you can see, it's 1, 2, 3, 4, 5, 6 width already, so that has to be our 30-foot side. And then we got to go 7 up. 1, 2, 3, 4, 5, 6, 7. Okay, draw 6 over and connect that down. Okay, there we have our garage now. It is 30 feet because we use 6 and by 35, which is 7. So there, that's all we're doing there so far. Now the last part, it says in the bottom left corner, draw a room that is 20 feet by 25 feet. So bottom corner right here, 20 by 25, I'm going to go up 20 and then over 5 because 5 times 5 is 20. In there we have that 3rd room. So we can use this when drawing scale drawings of houses, floor plans, as well as other things. Having the grid makes it a lot easier. Otherwise, you have to get out a ruler and measure to find find like what an inch or a centimeter represents in feet and go from there. But if we can assign a measurement to each one of these squares, it just makes it that much simpler. Okay, and then last thing, it just says draw a scale copy of the polygon that is 2 times bigger than the original, starting at the dot closest to the polygon. So here's the dot closest to the polygon right here. So 2 times bigger, we're just going to multiply every side by 2. So this width here is 3, so 3 times 2 is 6. So we're going to go down 6. 1, 2, 3, 4, 5, 6. Okay. We're going to go back 3, or it goes back 3, so that's going to be once again doubled. 3 times 2 is 6. Okay, you go down 3, so once again you're going to go down 6. Okay, so whatever the length is in the number of squares, we're just doubling that. Okay, so we've got 4 here, so that's going to be 8. 2, 4. Okay, and then this is going to go up 4, so it's going to go up 8. Okay, our top one, it's 5 across the top, so 5 times 2 is 10. see if that's 1, 2, 3, 4, 5, 6, 7. Oh, went too long, one too many. Okay, and then this comes in 1, so if 1 times 2 is 2, then we can just connect. Okay, and so there we've doubled the original by 2. So once again with the squares, it's easy to just look at the number of squares for the width and the length, and then just multiply that by the factor, which in this case was 2. All right, and that's just a recap kind of drawing something to scale. A couple different things. We start off with a map and how to use that scale. Then we were just given it was just a rough drawing of a park, and it was on these squares, and instead of having to measure, it just stated what each square, or which 2 squares equals. Similar with the house, we drew the house floor plan following what the scale factor was, which was 5 feet for 1 block. And then the last one, this was just in general understanding that if you're going to double something, you just have to double every length in it. So that is just a recap of scale.